Yeah, once again, I welcome you all for another very beautiful presentation on electronic devices and circuits subject. In today's presentation, I would like to explain you about the configurations of transistors. Right? We'll see the configurations. Right? The configurations of transistors. The configurations of transistors, right? So in the last presentations, if you recall, we have seen the basic information about a transistor, as a transistor can be electrically shown like this we have seen already. This is an NPN transistor. This is the emitter terminal actually. This is the collector terminal. This is the base terminal. This is the emitter terminal in general. Here the arrow mark indicates the direction of flow of current. Actually, this is basically it is an NPN transistor. This is NPN transistor. This is N and this is P. This is N actually. NPN transistor. And similarly, if you write the PNP, simply you can show that arrow mark in reverse direction like this. This is what your right. So this is what your PNP, right? This is your base terminal. This is what your emitter, okay? This is what your emitter terminal, and similarly, this is what your collector terminal actually. And again, here the arrow mark indicates the direction of flow of current, emitter current. Here, the flow is like this, as the arrow mark is going outward direction, so the emitter current flows like this. Emitter will goes out, and your base current will goes inside. This is IB, and similarly IC will come actually in this way. This is IC. Similarly, in NPN transistor, it is upward direction. Therefore, your current must be in upward direction, IE. The emitter current must be upward direction, because here the direction is upward. Therefore, your direction of current is also goes in upward. So it is going to the node. Therefore, these two currents leaves from here, means the base current is like this again. It goes like this, and here the collector current goes upward direction, right? These are the basic representation, electrical representation of a transistor or BJT. This is the NPN transistor. So NPN, here PNP. This is what we have seen basically, right? And as we have three terminals, these are called emitter terminal, base terminal, collector terminal. This is called emitter, this is called base terminal. B stands for base, right? And C stands for collector. Similarly, here also the same. E stands for emitter, B stands for base, C stands for collector. Emitter, base, collector in both the cases, right? As it has three terminals, so this transistor can be operated into three configurations. One is the CB configurations, right? That I will explain you now, right? That I will explain you. And so here, before going to the configuration, or otherwise I will write the configurations. As we have three terminals, therefore depending on the terminals, we can operate the transistor into common base. The first one is common base, or simply you can write CB configurations. CB configuration. And the second one is common, the second one is common emitter. The second one is common emitter. In short, you can write CE configuration, right? Common emitter configuration. And the third one is CC, nothing but common collector. What is this? Common collector, or in short you can write CC configuration. These are the three configurations in which a transistor can be operated. The first one is common base configuration, the second is common emitter configuration, The third one is common collector configuration, right? So what do you mean by common actually? What do you mean by common base? Because common base is nothing but the base terminal is kept as a common with respect to the remaining two terminals, nothing but the remaining two are emitter and then collector. Therefore, the base terminal B will be used as a common or a reference one with respect to emitter and then collector. That is the meaning of common base, right? Similarly, in common emitter, the emitter terminal kept as common. The emitter terminal will be kept as common, means as a reference with respect to the remaining terminal. So, other than emitter, what are the remaining two? Collector and base. Therefore, emitter is common with respect to base and then collector. That is the meaning of common emitter. And what is the CC? Common collector. So, in common collector, the collector terminal will be kept as common and with respect to the remaining two, nothing but emitter and your base terminal. Let us see one by one what will happen actually. So, in as far as your academic point of view is concerned, so in your examinations in academic or university college examinations, definitely they will ask you an examination, write the CB configuration of a transistor or explain the CB configuration. So, in each of these three configurations, you will be asked the input and output characteristics of either CB configuration or the input and output characteristics of CE configuration, or otherwise the input and output characteristics of a CC configurations. So, this is very important question actually in examination in as far as your academics is concerned, right? But as far as your competitive examinations is concerned, so this particular theoretical part or this is not that much important. Directly you have to go through the equations directly, right? That also I will cover after completion of these particular or in subsequent presentations. I will elaborately and very clearly I will explain you in your competitive point of view also, competitive examination point of view also, right? This is as far as your academic is concerned, right? So a transistor, okay, here transistor is nothing but BJT. So consider here I am considering as BJT, bipolar junction transistor only now. So this is nothing but with respect to your BJT actually, common base, common emitter, common collector, right? So one by one we will see actually what is a common base, what is a common emitter, what is a common collector. So if a transistor, if the NPN and PNP just now we have seen, if you take the NPN transistor, how this NPN transistor can be connected in CB configuration, right? How the same NPN can be connected in common emitter configuration, and similarly how the same NPN transistor can be connected in CC configuration. I think we need each of different presentations. It is quite to feel a little bit, complex and to remember or to understand. Therefore, right now I want to finish the common base configuration in this particular presentation, and remaining two we will see in the subsequent presentation. Let us focus on common base configuration, right? What is a common base configuration? How it look like, right? So let us see. Before going to explain about this common base configuration, I will explain you the basic, NPN transistor. If you see the physical structure, if you see the physical structure actually, normally, as I have already explained you in very beginning presentation, if you recall that, right? This is what the NPN, let us say, this is NPN transistor, let us say, physical construction, and here the terminal is emitter terminal obviously, and the middle is your base terminal definitely, BASE, right? Base, BASE, emitter, EMITTER, this is emitter terminal actually, and definitely this is your collector terminal, C. C stands for collector. Already I have explained you in the first presentation that, so this particular region, this particular NPN it is a heavily doped region. It is heavily doped. It is heavily doped actually, and this is something lightly doped. This is called lightly doped region actually. The base is always lightly doped. That's why it is something thin if you compare with the remaining two portions. So this will be thin actually. The width will be very less base terminal. It is lightly doped. Whereas this particular is something, it is moderately doped. It is moderately doped. So sometimes may be important as far as your competitive examination is concerned. So the doping concentration or the doping level of NPN material, how the doping level will be done in transistor, it may be asked, right? So how the emitter is heavily doped, remember, it is heavily doped, it is lightly doped, it is moderately doped. Now what happens actually, so how the flow of the electrons will happen in the transistor. Remember that the flow of the current in the transistor is due to both the charge carriers, both the majority carrier as well as the minority carrier. That's why the name BJT has come, bipolar junction transistor. By the way, this is obviously, this is N and P. In between these two we have one junction here. Definitely it is a junction. You can call it a junction 1, no problem. And similarly, again if you consider P and N, this is the junction, another junction, then you can call this as junction number 2. This is the junction 1, this is the another junction. Two junctions are there. In this way also you can call the transistor as a bipolar junction transistor. Bipolar junction transistor. Okay. Now what happens actually? So this particular emitter terminal will injects or emits the electron. Actually what happens, so this particular emitter, he injects electrons actually. So just I will explain you like this. So the electron, it will inject the electrons into the base actually. These are the flow of electrons, let us say. So like this in base region, right? In the base region from emitter to base region, so the electrons will flows like this towards base, right? So the electrons will be injected or they are injected or emitted from this emitter towards the base. Now these electrons will passes through this base, and finally these electrons will be collected by the collector. These electrons which are there in the base, actually these electrons can be, the collector will be collected these electrons. That's why the name collector. So actually finally these electrons will be collected by the collector actually. So finally, therefore finally the electrons are, so they will start from their flow from emitter, finally they reach to collector. That's what happens actually. They start from here and they will be collected by the collector. Clear? That is what actually in the emitter terminal. In the emitter terminal, if you see, what is the current, it is called emitter current. IE is the emitter current. Clear? And in base terminal, what is the current, this is called base current. So the current which is there in the base terminal is called base current, and here the current in the collector terminal is denoted by IC, collector terminal, right? So as the layer of this P type or the base terminal is very thin, obviously the base current is also very small, remember that. So as the layer is the middle portion, the middle portion is very thin, and this is of base actually. This middle is nothing but base terminal. As the width is very less, therefore the base current is also very less. IB is also very less. Therefore, as far as this picture is concerned, you can treat your IE as input current here, and you can treat your IC as output current basically, because this is the input terminal now and this is your collector output terminal, let us say. Therefore, now I am going to give a relation between IC and IE. So how I can write? So here IC is equal to IC is equal to, I can give one relation here. This is nothing but IC, collector current. IC is equal to, normally it is given as fraction of emitter current. That can be given as fraction of emitter current. So this is the relation actually. So your output current IC is equal to some alpha times IA normally. Alpha times IA means alpha is a fraction of emitter current. Okay, fraction of emitter current will be collected by this collector terminal, and therefore if you give the relation between current, output current IC and then IA, therefore IC is equal to alpha is the small portion. Okay, so alpha times IA, alpha into IA, that is the relation actually. Now from here I can erase this particular diagram, and I will give you one important definition for this alpha. So from this relation, if you see, right, from this relation, IC is equal to actually alpha times IA. Therefore from here this implies you can write what is alpha. Alpha is equal to, it is simply IC by IA. Alpha is nothing but IC plus IC by IA. Call it as equation number 1. What is this? Current gain actually. So this is, if you see, it is the ratio of currents. So IC is the output current, whereas IA is the input current, right? Therefore if you take the ratio of output current IC by input current IA, then that ratio is called as alpha, and it is called as current gain. What is this? It is current gain. It is current gain. Alpha is the current gain. Obviously, the first configuration which we are going to see now, that is called CB configuration, right? CB configuration. Is it not? The first configuration which we are going to now discuss, CB configuration. In CB configuration, this particular base terminal will be kept as common. Your base is kept as common. Therefore, in this case, the emitter terminal will be considered as input terminal, and the collector terminal C shall be considered as the output terminal. Emitter is input, collector is output. In CB, base is kept as common. This is input and this is the output, right? So obviously this in this case, so if the emitter is taken as input, then what is the current? Emitter current is the input current, and here as C is considered as the output terminal, then current correspondingly the collector current IC can be taken as output current. Therefore what is the ratio? Output current by input current, that is nothing but IC by IE. That is what this only, IC by IE. Therefore output current by input current, IC by IE, nothing but this one only, that is current gain. Therefore what is alpha? You simply can say alpha is the current gain in CB configuration. Your alpha is nothing but current gain in CB configuration, right? CB configuration. And normally remember that the current gain value is very, very less than 1. The magnitude of alpha is nothing but the current gain, and the magnitude is alpha is less than 1. Remember that alpha is less than 1, and normally it varies from alpha is equal to some 0.98 to it varies 0.995. This is the value of alpha normally. This is the value of alpha. Alpha varies from 0.98 to 995. In some textbooks, they may give you maybe 0.95, no problem, nothing wrong in it. So 0.95 to 995, or sometimes 0.98 to 995. In either case, it is less than 1. Therefore, it is less than 1. The value of alpha is less than 1. What is alpha actually? It is the current gain in CB configuration, right? Remember that this is very important point. The relation of alpha is very important, and the value of alpha is also very, very important actually in examination point of view, right? Now I am going to give one more important relation here. Now I am going to give you one more important relation. Let us see. Now I am erasing this particular And so by considering this particular equation as 1, by considering this particular equation alpha is equal to IC by IE as equation number 1. Now for any transistor means that what actually? For any transistor, this is transistor, clear? This is your terminal emitter, we know that already. This is the base and this is your collector, is it not? Clear, this is what I already know. So let us say it is a NPN, then the current flow is, it is IE and IB goes inside and IC comes inside. What is the relation between in these three? So that is nothing but IE, emitter current, is equal to, from here, IE is equal to base current plus collector current, is it not? So the emitter current is equal to sum of base current into collector current, is it not? Therefore we have seen that you substitute IC is equal to what actually? What is IC? IC is equal to what? So from this relation, this is 1, you can take it as maybe equation number 2, and now you can take it as equation number 3. No problem. You can take this alpha as 1 and this relation as 2, and this can be, you can take as 3. Now substitute this IC value, IC is equal to alpha times IE. Then if you substitute here, substitute 2 in 3, substituting 2 in 3, substitute equation 2 in equation 3, then what you will have actually, you know? So what IE, so IE is equal to, so you have IB, clear? So this is equal to, what is IC? It is alpha times IE, clear? It is alpha times IE. Now here take IE as common, because IE is equal to IB plus alpha times IE. Now bring this alpha times IE to the left side of this equal. Therefore IE minus alpha times IE, is it not? Take IE as common, then what you will get? 1 minus alpha, clear, is equal to, it is IB. It is IB, clear? 1 minus alpha, is it not? So from there, so just I will erase so that you will understand very clearly that relation. Just I am going to bring a very important relation now. What is this actually? From this, it is, what is this? So IE, if you take IE as common, IE is equal to, it is 1 minus alpha is equal to, it is B actually. Then what you will get? From here, what you will get? IE, or otherwise IB by IE you can write, okay, or otherwise output by input, because here there are 3 configurations basically, CB and then CE and then CC. So in CB configuration, emitter taken as input and your collector taken as output, collector terminal. Emitter terminal will be considered as input terminal, collector is considered as output terminal. Again in CE, emitter is ground actually, therefore your base terminal will be taken as input and C is taken as your output. Whereas in common collector, collector will be kept as ground, common, therefore your base is input and your emitter is output. So therefore remember this particular sequence, this is very important actually, right? In common base, emitter is input actually, this is output term, emitter terminal is input, C is output. In CE, base is input, collector is output. In CC, base is input, emitter is output actually. Therefore from here what you can write, you know, output by, so it's something IE by IB. You can, if you take the ratio from here, IE by IE, IE by IB, nothing but output current. Actually, this is with respect to your CC configuration. CC configuration. Clear? So then what you will get actually? IE by IB is equal to what you will get? 1 by 1 minus alpha. 1 by 1 minus alpha. This is one relation actually. 1 by 1 minus alpha. So remember here I am going to explain you that the current, so here in common base configuration, alpha is the current gain. In CB, in CE configuration, the same current gain denoted with beta, and in CC configuration, gamma is the current gain actually. These are three important parameters should be remembered. Alpha is the current gain. What is the current gain? IC by IE. These are the current, remember that. So the current values are very important, input current, and then these are the output current actually. So these are, we have to consider the current flowing through these terminals and also same current flowing through these terminals. Therefore, here if you consider the alpha, alpha is nothing but from here IC by IE. Alpha is equal to IC by IE. Clear? Sorry, because in common base, your base is common, therefore emitter is input, collector is output, therefore output current by input current, IC by IE is alpha. And similarly, come to the CE configuration, there beta is the current gain. What is the output? Current IC by IB. IC by IB actually in common emitter. Whereas in common collector, it is gamma actually, IE by means emitter current by IB base current. This is what actually I am giving now. Therefore, what is this ratio, you know? So this IE by IB is nothing but your gamma. Nothing but your gamma. Therefore, gamma is equal to 1 by 1 minus alpha. 1 by 1 minus alpha. Like that. This is one relation. And so, right. So initially I have given three expressions. So if you substitute little bit conversion by substituting one equation into another, you will get one important relation between these three parameters actually. These three parameters. Okay? Is it not? Alpha is equal to what you will get. You just simply, you simply substitute the equations 1, 2, 3. You solve for equations alpha, beta, gamma, you can get alpha is equal to, it is beta by 1 plus beta you will get. Is it not? And beta is equal to alpha by 1 minus alpha you will get. Simply by rearranging these three expressions, means 1, 2, 3. If you rearrange those equations by substituting one into some another, and you will get the relations for alpha, beta, gamma. Alpha is equal to beta by 1 plus beta you will get. Is it not? And beta is equal to alpha by 1 minus alpha. Is it not? Therefore, gamma is equal to 1 by 1 minus alpha, or in terms of beta, if you write gamma is equal to 1 plus beta also. So in terms of beta, gamma is equal to 1 plus beta, and in terms of alpha, gamma is equal to 1 by 1 minus alpha, and alpha in terms of beta, beta by 1 plus beta, and beta in terms of alpha, alpha by 1 minus alpha. Very, very, very important relations. Very important relations. Therefore, clear, these are very, very important to remember. I think this is what I want to explain you in this presentation actually. Okay, and the value of alpha, I have already explained you that, I have already told you that the value of alpha varies from actually 0.982 to 0.995. If you substitute any value, this is the minimum value or this is the maximum value, whatever you take actually, if you substitute this particular alpha, either this value or this value, and normally if you take the minimum value, say for example, and if you substitute 0.98 by 1 minus 0.98, if you substitute, approximately you may get something 50 around that you will get. So therefore, so means that what actually so normally the current gain in the CE beta is the current gain in the CE configuration, and the minimum value is 50. Normally this beta varies from 50 to 200 normally. Normally, the beta value varies from 50 to 200. So the current gain is more. Whereas the alpha value, what is alpha? Current gain in common base configuration. Beta is the current gain in common emitter configuration. You can see this is CB configuration, current gain in CB. This is current gain in CE. What is gamma? It is current gain in CC configuration, right? So it is beta 50 to 200. Okay, now consider the beta value as 50 as a minimum value. Substitute this minimum value into gamma. Therefore, gamma is equal to 1 plus, let us say, here for this beta, substitute the minimum value, take the minimum. So it is 51. Means that what? Still the current gain in the CC configuration. This is the current gain in CC configuration. It varies from 51. Okay, the current gain is more. Therefore, these are the basic definition or relations between alpha, beta, gamma. Clear? Therefore, alpha value is very less. Remember that alpha value is less. It is less than unity. Alpha is nothing but the current gain. What is current gain? Output current by input current. Output current by input current. That is what current gain. Gain is nothing but ratio. Gain is equal to ratio. Output by input is the ratio. If you take those input output parameters as a current, it is called current gain. Therefore, alpha is the current gain in CB configuration. Beta is the current gain in a CE configuration. In CE configuration, what is the output current? Collector current. What is the input current? Base current, right? Similarly, in CC, common collector, so a common collector terminal will be kept as ground. Therefore, your input is base and your output is emitter only. Therefore, emitter by base. These are the relations actually. Therefore, so the values also we have to remember. Alpha value 0.998 to 0.995, and if you substitute those values in these particular relations, you will get the minimum maximum values of beta and then gamma. Clear? I think we'll finish this particular presentation here, and let us see the input and output characteristics of CB configuration in the next presentation, in the subsequent presentation. I hope that you understood this very well, and I request you all to give your valuable feedbacks and comments and suggestions, and don't forget to share these particular videos to your friend circles, friends and relatives, so that the needy people, especially those who want to get the information and those who are really seeks that, so they should not miss this. Okay, so I wish and want to reach this information to the every student, and every student shall be benefited, right? And I hope you understood this particular, and we'll meet in the next subsequent presentation. Okay, have a beautiful day.